Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back team, and let's continue our discussion. So we are just doing some best practices and the improvements in our AWS to to make it more better infrastructure deployed on AWS cloud to run our web applications, right? So as part of that, we are discussing about how do you set up your own networking configuration to deploy your infrastructure stack in AWS cloud, right? So in my AWS cloud, right, currently the VPC and all the different VPC related components that I have got set up is still there. I can see my VPC is there, and I can see one public subnet and one private subnet, and I can see a public route table, a private route table, and the internet gateway. Pretty much everything is ready for me to go ahead and create a EC2 instance, right? So I think let me go ahead and create a EC2 instance quickly, right? So I'll just go and launch a EC2 server quickly in the customized VPC, not on the default VPC, right? So let's say I wanted to deploy a EC2 server, which I wanted to make it as a web server, right? I want to run my web application, right? That's my goal. So let me deploy the EC2 instance, and let me choose the Amazon Linux AMI as usual. And let me go with the t2.micro, and let me use the key pair and edit the networking settings and choose the custom VPC web VPC 01. And tell me guys, you want me to choose the public or the private subnet here? My goal is I want to use this EC2 server, right, installed and configured as a web server and run a website from this machine, right, which I wanted to use for my business use cases, right? So always as a best practice or as a security standpoint, right, it has to be a private server, correct? So let me go and choose the private subnet from the list here, so that I will get only the private IP. I will not get any public IP, and that's how my server will be little secured. Okay. Now I don't need any public IP. Let me go and choose the security group from the drop down. Good. Now let it be the default root volume. That is good enough, right? So if I go to the advanced details here, right, in the advanced details, I think we have already covered about the IAM instance profile. This is where we can attach a IAM role for your EC2 server, right? So I think this is the role that I have created the other day, EC2 role, right? So let me select the role, and before that I will go and verify what and all permissions are given for this role. Okay, if I go to the IAM and role section and look for the EC2 role that what we created, right? So what is the role name, guys? EC2 underscore role, right? So EC2 underscore role. So if I look into the permission section, I can see there is a SSM permission is already granted. So that means the session manager should able to give you the session of this EC2 server, right? Good. Now just go ahead and launch this instance. I just have deployed a EC2 instance in the customized VPC in the private subnet and have attached a IAM role for this EC2 instance. So when you look into the EC2 instance metadata, right, this instance has got only the private IP. And can I use this private IP for logging into the instance from the PuTTY? No, right? It will not be accessible. this IP will be accessible only within the VPC level, not from the public internet. Now, how do I logging into this instance, right? So that is where we need to go to the connect option and use the session manager here, right? So the session manager should help you to logging into this instance, right? Because the IAM role is already granted. So this is one best way to access your private EC2 instances, because you can't access those from your party directly. So let me wait for some time, because once the instance is deployed, the SSM agent must be up and running in the instance. Then only the instance will be accessible from your session manager, right? So it may take some time to fully settle there. Okay, so let me try now. Still the session manager is not working. Right, so while that is happening, right, let me go ahead and deploy one more server. Okay, we'll give some time for this server to come up. So let's say this is my public server that I'm creating. You will know the use case of the private public server. I'm just using AMI T2.micro. Let me deploy a key pair, edit the networking, select the customized VPC. Now I'm just using the public subnet here, and I would need a public IP for my public server. Let me enable the public IP. Now let me attach the security group, right? So as usual, I will give the EC2 role as well. Now let me go ahead and launch an instance. So this is the public server, guys. I have one public server, I have one private server, both. Okay. So if I look into the public server, it has a public IP and the private IP, right? I can use the public IP for logging into the public server, right? So this is how it will be. It is just taking some time. I will try again, refresh, take the party. Let me logging in one more time. EC2-user is the default username, and let me switch to the root, and that's it. Here you go. This is your public server, right? And of course, that's how it works. Now, let me see if my private server is still accessible from the session manager, right? So take this private server. Let me go to connect option. You see that the session manager is still not working. That's fine. There will be some reason why this is not working, right? So ideally, yes, the session manager is the one which you need to use to logging into your private servers. Let's say your session manager is not working for any reason. Even at this time it is not working, right? So how do you get into the server to see what will be the problem and any other things, right? So that is where you need to use the public server as the jump server to logging into the private server. So if I take you guys to this architecture one more time, right? You see this, whenever the users wanted to logging into the private servers from the public internet space, since the public users cannot log into the private server directly, the public user first can logging into the public server, right? From the public server, we can logging into the private server, as the public server is now able to connect this private server using the local gateways using the private IPs, correct? Hope you are getting me, right? For that matter, it doesn't need to be a public server, guys. We already familiar that, right? All the EC2 instances within the VPC can be communicated each other, correct? No matter that is a public server or a private server, all the EC2 instances can be connected using the private IPs, using the local gateways within the VPC. So the user first can log in into the public server. From there, right, we can log in into the private server using the private IP. Let me show you that approach now. So now currently here I logged into the public server, right? From here I would like to log in into the private server. Help me guys, first of all, how do we understand that the private server is accessible from the public server? What will be the commands that I can use, right? So I'm just trying to verify, first of all, this server is accessible or not, right? Telnet and the target IP address, and let me verify the port number 22 is accessible or not, right? The telnet is the best command to verify the port reachability, guys, right? The ping command will not tell you whether the port is reachable or not. If the ping is working, is not mean that your server is accessible on the designated port number, right? We always need a port to be available, reachable to access that particular port binded services, right? So you see that the telnet is not there. That's fine. Let me go to root yum install telnet. If the telnet is not available, I can install the telnet as well. You see now the port number 22 is reachable. Good. Now we need to logging into the server. So this is where like we can use the ssh -i, specify the key, then ec2 hyphen user and at the rate and the IP address of your destination server, which is the private IP of your private server at this time. Now in order to log in, you need a key, right? The very first time when you're trying to logging into the server, you would need to provide a private key, right? So we need to use the private key now. So the private key that you are using in your putty, like at the time of logging into the servers from the putty, right, that key will be in a .ppk format. If you are using the key in a Linux terminal level, the key should be in the .pem format. So for any reason, if you don't have the PEM format key, you need to convert the key by using the software called Partition, right? I'll show you how to do the conversion now. So Partition is the software which will be helping you to do the key conversion, guys, from PPK to PEM or from PEM to PPK. So in this case, like I have the key with me in my local system. I think dpt11 dot, yeah, you see that. So this is the key that I have in my local system, right? But this key is in the .ppk format. This key will help me if I need to log in from putty. But if I'm logging in from any one of the another Linux machine, this key will not help us. So we need to use the key in the .pem format. So we need to convert this key to the PEM format. How to do that? Let me show you the steps that are documented in our portal, guys. Right. So if I just come to the documentation, AWS documentation, why I'm covering this now? Because I got the use case, right? So here, this is the documentation which explains how to download the partition software and how to convert from PPK to a PEM format. So let me open the partition software, right? And let me click on load option. Okay. Now attach the key dpt11.ppk. Okay. Then what? Right. Then go to conversations and export the open SSH key. Okay. I'll go to conversations, export OpenSSH key, right? Now let me save this key, isn't it? Click on yes, then save the key. Let's say this is DPT11 PIM format. I can even make it as DPT11 for Linux purpose, just for understanding which key is in a PIM format. Save the key, close it. Now let me open the key, DPT11 underscore Linux, right? This is in the PEM format. Let me open this file. Let me open this file in the notepad. You see, this is the key, right? Let me copy this key. Now this key I'm using in my Linux server. VI, let's say dpt11.pem. Copy paste the key. Save the key. You know, right? The key should have 600 permission for security reasons. Now SSH-I, specify the key that you have now, and then specify ec2-user and this is the IP that I wanted to log in. Let me hit enter. As usual, right? The first time it will ask you that, hey, give the confirmation for the fingerprint verification. Give yes and hit enter. Now you see that what happened. Which command is not found? It looks good. Let me try one more time. Thank you. Right. So now you see that the SSH is working. I'm able to logging into, right? I just removed this last 22. Okay. So that's how you can logging into the private server from the public server, guys. Now I can jump onto the root. Currently, I'm in the private server, right? Good. So let me see systemctl status Amazon SSM agent. I'm just trying to check the status of the service. The service is actually running, so it should work from the session manager as well. Okay. Let me try one more time. I'll select my web server, go to connect. That's okay. So the session manager may take some time, so it should work. Okay. Anyway, we already familiar how the session manager works, right? Let it take its own time. Okay. Cancel. As long as the role is attached and the SSM agent is up and running, it should work. If it is not, give it some time. It should definitely works for you. Okay. Now, in this architecture, right, the public server, I'm calling it as a gem server. The only reason is I'm using this instance to logging into my private servers, right? Hence the reason the public server, I'm calling it as a gem server. From the AWS terminology perspective, this public server is called as a bastion server or bastion host. Bastion host terminology referring that the server which is used to connect it to any other server, right? That servers, I'm calling it as a bastion server. Mostly in the real time, the public servers will be used as a bastion servers only, not for the real business purpose. Even here, am I planning to use this public server to run my website, guys? Not really, right? I don't want to install and configure the web server on the bastion host. No, the bastion host is just a gem server which will help me to logging into my private instances if in case I need to logging into them directly. That's just a backdoor kind of, right? But you will never be using these public servers for running a business. To run a business like a website, you always run it from the private server only. right? So just to make it more alignment, right, this public server, I'm just updating it as a based on host. I'm just changing the name now, right? So this is the based on host now because I'm using this to logging into my actual web server where I'm trying to configure my web applications, right? So so when you are deploying this private server, right, let's say this is the private server, okay? For this EC2 server, which key that is being attached? You see this DPT11 is the key that is attached. When you have created this DPT11 key, that time you might have been downloaded one private key in your local machine, right? The same key that you need to use now to logging into this server. Whether you log in from party, whether you log in from any other machine, either the way, you just need to attach the key because the key format has to be different. I just have converted my key which was downloaded and kept in my local, right, and used that key in a different format to logging into the instance, right, the very first time that I'm trying to. Later on, as we know that we can always create our own SHS key pair and even configure it as well, not a worry, right? Now, right, so uh, as I see in a chart window, right, what if the key format is PEM? If you have the key already in the PEM format, you don't need to convert it, right? Since I have the key in the PPK format, which was downloaded and kept in my local machine, now I need a PEM format because the key should be in the PEM if I'm trying to use it in the Linux machines. So I just need to convert it. If you have already downloaded in the PEM format, why do you need to convert it? You use the key directly, copy there, and just use it over there, right? Right? So always you should be having one private key and one public key. The private key should be there in the client side from where you are initiating the connection. The public key should be there in the server side to which server you are trying to do the connection. As we already discussed that whenever you launch a EC2 instance and attaching a key pair, the the private key is already there with you, which was downloaded at the time of creating a key pair. The AWS will ensure that the corresponding public key will be get copied it into the EC2 instance under slash etc slash sshs and slash, right, sorry, slash slash home slash the user's home directory slash dot sshs slash authorized underscore keys file, correct? I'm going all the recap, right? Anyway, so the story here is I just logged into the private server here, and this server I wanted to make it as a web server to run my web application. That's the goal. Help me guys, the command that I need to run here in this private server to configure it as a web server. Currently I am in the private server, guys. If you look into the IP, which is kind of 1.92, right? So this is my server. Which command that I need to run, guys, to make this as a web server, right? So yum install httpd is the command to install on my, currently I'm working on the private server, guys, not on the public server, right? So you realize that the yum command is not working. Why the yum command is not working? Right? Whenever you run the yum command to install the package, your instance has to connect to the internet and download the packages, and then the package has to be installed, right? Always go with my concept, guys. Correct. So assume this is the EC2 instance where I'm currently running my yum install command. This is the private server, right? When you run the yum install httpd command, this server, right? This private server should connect to the public internet to download the packages. How it can connect it to the public internet? Let me come here. Sorry, guys. Let me come here. You see this scenario, right? So this is where my private server, I'm running the m command to install the packages. Do you think this private server has the connectivity to access the internet gateway to connect it to the internet? No, right? So this private server does not have a outbound or inbound internet connectivity. Hope you can understand the terminology called inbound and outbound. Inbound in the sense that the data which is coming to the server, outbound in the sense the data which is going out from the server. Currently, this private server does not have any inbound or any outbound internet connectivity. So when you try to run the yum command, it is failing because it is not able to connect it to the outbound internet. Now help me guys, how I can give the internet connectivity for this private server, right? The server is always taking the help of the route table to know how the data packet or how the request has to be routed, right? If you update the route table by adding the default gateway entry to route the traffic to the internet gateway, yes, then your private server can have an access to the internet gateway the way how your public server also has the access. But that is not our requirement, right? My EC2 server should not be accessible from the public internet space because I wanted to make it more secured. So can I use this statement at this time? The way how I'm expecting my private server to be working is the inbound internet connectivity should not be working in the sense the users from the public internet space should not be connecting to my private server. However, my server should be able to connect it to internet to download the packages, correct? Just to repeat, I'm expecting my server should have the outbound internet connectivity to connect it to internet and download the packages required, but my server should not be having any inbound internet connectivity. That means the user should not able to log into my server, but the server can connect to internet. That is what I'm trying to look at here, right? To achieve that, we need to create a NAT gateway. You see here, I'm creating a NAT gateway, which is one more gateway type. NAT in the sense network address translator gateway. I'm creating a NAT gateway in the public subnet. If you closely observe, guys, right? When you create a NAT gateway in the public subnet, the NAT gateway can use the public route table and can use this default route entry and can connect it to the internet gateway. Am I good with this? Just to repeat, whenever you create a NAT gateway in the public subnet, the NAT gateway is now having an access to connect to the internet gateway, then to the internet, correct? Because we already know that anything that you create in the public subnet, all of them will be using the public route table and will be connecting to internet gateway by default when the destination is not matching the rules, right? Being said that, can I say that the NAT gateway which is created in the public subnet can access the internet gateway? If yes, the next question for you guys, either it is a NAT gateway or it is the EC2 server or it is something else. Usually in the networking terminology, everything should have a IP address and those should be communicated each other, right? Now the question for you, do you think the private EC2 server can connect to the NAT gateway? NAT gateway is in the public subnet, private server is in the private subnet. Okay. Do you think the private subnet server can connect to the NAT gateway which is in the public subnet? Obviously, yes. Why? The private server, the NAT gateway, both are belonging into the same VPC. When these two are belonging into the same VPC, these two can be communicated each other using the local gateways. So now if you closely observe, right, the private route table I am updating one more entry saying that the default gateway should be a NAT gateway. Now you see how it works. Whenever the private EC2 server wanted to connect to the internet, it will look into the route table. Hey, I want to connect it to the internet and tell me how I need to route the packet. The first entry says that, hey, if your destination is within the VPC, use the local gateway. No, my destination is not within the VPC. My destination is internet. Okay, then use the default entry. The default entry says that give the request to the NAT gateway. So now when this is trying to connect it to the internet, right, the private server will be sending the request to the NAT gateway saying that, hey, I wanted to connect it to this Amazon repositories to download the packages. That request is now sent to NAT gateway. The behavior of the NAT gateway, right, which is the network address translator, the NAT gateway tell that, hey, I got your request. On behalf of you, let me go and connect it to the internet and let me download the packages and let me give the response back to you. That means on behalf of your private server, NAT gateway is connecting to the internet, getting the response. The same response will be giving it back to the requester, who is a private server in this case. That way, your private server is not really exposed to the internet, guys. Following me? My private server is able to connect it to the internet and download the packages. That is true. But again, your private server is not connecting to the internet directly. It is going via the NAT gateway. NAT gateway is playing the game here, which is connecting to the internet and downloading the packages and giving it back to the actual requester here. The NAT gateway will provide only the outbound internet connectivity to your private servers, not an inbound. The public users cannot go via the NAT gateway to reach my server, no. But the server can use the NAT gateway to reach the internet and download the packages. Are we good with this? So simply put, the NAT gateway is the gateway that the AWS has introduced, which will allow to provide a outbound internet connectivity for the private EC2 instances, so that the servers can connect to internet, but from the internet you can't connect to the private servers directly. That way your servers are still secured. If you are good with this, let me go ahead and deploy this. Right. So in the VPC dashboard, guys, and if you do a little scroll down, somewhere you can see a NAT gateway. Currently, the NAT gateway is empty. Before I go ahead and create a NAT gateway, I really wanted to come back to the subnet section and let me show you the public subnet, guys. If you look into the public subnet here, you make a note of this. The available IP addresses are 250. That means in this public subnet, as of now, there are 250 private IPs are available. I mean to say, it's a private subnet. Since it is attached to the public route table, sorry guys, right? Since it is attached to the public route table, which has a entry to route the internet gateway, I'm calling it as a public subnet, but it is actually a subnet, right? Which has almost 250 IPs available over there. Okay. Now let me go ahead and create a NAT gateway. NAT-01, I'm just giving some name. Tell me guys, I need to deploy the NAT in a public subnet or a private subnet, right? I need to deploy it in the public subnet. Connectivity type, I need a public subnet because my requirement is to connect it to the public internet. Now, if your NAT gateway has to be connected to the public internet, your NAT gateway must be having a public IP, correct? We already experienced that. Even if I go back to the bastion host, which is the public server, you see it has a public IP. It has a private IP also. Public IP for connecting to internet, private IP for connecting internally. Same concept will be applicable here as well. So click on allocate elastic IP. That will take one public IP and attach this public IP to your NAT gateway. Now just come down and create a NAT gateway. Right now the NAT gateway is created and the required IP addresses are being assigned. You see here, I think it takes 2-3 minutes guys for it to be creating completely. Now you see that it is actually allotted with one private IP. Of course the public IP will come, right, and we can see the private IP as well here. So if you go back to your subnet and look for your public subnet one more time, now you see that the available IP addresses are 249. That means since you deployed the NAT gateway in the public subnet, it has taken one private IP. Also, it has taken one public IP. The public IP for internet connectivity, private IP for internal connectivity within the VPC. Now, if I come back and look at let me show you the things, guys. Yeah, if I come back and look at the network interfaces, you see that I have got a total 4 network interfaces. And if you look into the attachment, guys, and you see that one of the network interface is actually attached to the NAT gateway. Remember the concept. Each time when you are using the IP addresses, it is actually attaching to the network interfaces. The network interfaces are actually attaching to your specific things, right? And that's what I'm trying to confirm it again. So whenever you have used the NAT gateway, and you see the NAT gateway IP also here, so there is a network interface code is created and that is actually attached to your NAT gateway, guys. I'm just confirming that. Now let me come back here again. As you see a question in the chat window, the EC2 instance that is got deployed, yes, it has its own public IP. How I will be using this public IP to my NAT gateway, right? It would need its own IP address. The EC2 instance is different. The NAT gateway is different, right? The NAT gateway should have its own public IP, which will be used to connect it to the public internet space. Now done. NAT gateway is done. Let me come back and look at the status. Right? So now we can see that the NAT gateway is in the available state. Remember that the NAT gateways are not free of charge. This is not part of the free tier. The billing is applicable from the time when you deploy the NAT gateway. So please do remember to terminate the NAT gateway the moment when you have completed the lab practice. Once the NAT gateway is deployed, right? Now the thing is you need to go back to your route table, go to your private route table, right? Currently the private route table entry saying to route the traffic only to the local. Now edit the routes in the private route table, add a route. The default, the traffic should go via NAT gateway. So select NAT gateway from the drop down and you select the NAT gateway ID. Now you click on save. That way the private servers using this private route table can use this default gateway entry, then can connect it to the NAT gateway to access the internet. Now if I come back to this private server and let me run the yum command one more time. Now you see that it is working. It is able to connect to the internet, able to download the packages, the installation is done, but the private server cannot be accessible from public internet directly, guys. That's how the NAT gateways are working, right? So systemctl start httpd to start the service. Systemctl status httpd to know that the status. vi/www/html/index.html, that's the default file. I'm just preparing one simple file there. This is my website. Save the file. Now I configured a simple web application on the server. Now tell me guys, how do I access this website, the one which is currently configured in my private server? Previously, right? Previously, when I was configuring the web server on the EC2 instances, maybe here, right? In previous lectures, when the web server is installed and configured on a EC2 server, right? I used to take the IP address and either I go to the browser and access the website directly on IP address, or maybe give it in DNS and use the name, whatever it is, right? But now, do you think I can use this private IP to access the website from the browser? Not really, right? So your server will not be accessible from public internet space on this private IP, no. So you cannot access this website from public internet directly as of now because it does not have any public IP address for direct reachability, guys. Right? So in these kind of situations where your server will not be accessible from browsers, right, to verify whether your website is working or not, in that kind of the situation, you can use the curl command, right? Curl http:// and specify the IP. It's pretty much the same URL, but rather browsing it from the browser, I'm just running a curl command against that. If your curl command is working, you see the output I'm getting, right? If this is working, then this is confirmation that your web server is working at least. Got me? This is the way how you can verify the website is working or not from the command line interface. Of course, this is not the final output that I'm expecting, correct? I want to access this from the real public browser as like a real time. I'll show you how it is as well. So far so good. Right, so if at all your website has images and the videos, rather showing the images and videos, it will show you the HTML code, guys, if you are accessing it from the curl command. Let's say curl http://youtube.com. Why it's not coming? Maybe they have disabled this request. http:// right? So right, so you see a bunch of HTML code that have got as a response whenever it has some images, videos, a lot of things. You see it is actually having some images as well, but it will show you the corresponding HTML code rather showing the graphical user interface, guys. In fact, even when you are browsing this website from the browser, right, even here as well, it is actually getting the HTML code only. That HTML code is actually converted it into a graphical format by the browser. It's a browser responsibility to show your HTML code in a image format, not your web server responsibility. The web server is always giving the response as HTML code only. Got me? That code will be converted, will be showing to you in a graphical nice website format. That is the responsibility of the browser, not a web server responsibility. It's a client responsibility to take the response from the server and show it to you in a nice format, guys. So if you do a right click here and just click on view page source, you see actually your web server is giving the response in this format. This is what is the web server response, guys. This is just a HTML code. Your web client, which is a browser, has that intelligence to understand this particular code, and this code will be get converted it into a nice usable format. That's the reason when you are doing it from curl, the curl is the client that I'm using. The curl client does not have the capability to convert it into a graphical format, so it is showing the HTML code as it is. Are we good with this? Lot of things. Now come back to here. If at all you have deployed a web server in the private server and you are expecting that to be accessible from the public internet space, then you need to introduce a concept called load balancer, guys. Now I'm showing you how the load balancer works and why do we need to use the load balancer here in order to access your website which is currently in the private servers, right? So it will be little tricky to understand, but yeah, I'm just trying to follow you, make you guys follow on this. Again, I'll bring up some of the basics, guys. Let's say you have a EC2 instance which is currently configured as a web server. As of today, what we know that the end user, whoever is accessing the website, will be sending the request to your EC2 IP address, and the EC2 server will be giving the response back, and that response will be showing as a website, right? Good. So let me talk about some hiccups as here. What is the case if your EC2 server is down, guys? Let's say your HTTP web server is down, or your EC2 server is down, your EC2 server is stopped for any reason, your EC2 is terminated for accidentally, something has happened. If your EC2 server is not working, your website is down, there is a downtime, users cannot access your right website, your business is down basically, right? This is called as a single point of failure. Single point of failure is the terminology that we use, which is explaining that whenever you are using one single component to serve the business, if that particular component is failed, obviously your business will go down, correct? In this case, if you are using only one single EC2 instance to run your web server, if that server gets down for any reason, your website is down, business is down. Following me, guys? Which is not really the good practice when it comes to the real time. Have you ever seen like your youtube.com is going down? No. How that's happening? So behind the screen, it's not a one server the way how we did it just now. There will be multiple servers to provide you the redundancy. So rather me configuring one EC2 server to serve the website, now let me make a one more EC2 server as a redundant EC2 server to serve the business. If you are using more than one EC2 instances to serve the same website, guys, for any reason, if one server gets down, no issue, because there is a one more parallel server which is right serving the same website that will take the responsibility to serve the website. Are we good with this? When I'm introducing you the load balancer concept, the load balancer will bring you many advantages. I'm trying to call out all those advantages now one by one. The very first advantage is it will eliminate the single point of failure, right? How it's possible? First thing, whenever you are having two EC2 instances to serve you the website, do you think the end client, whoever is accessing the website, will be relay on the IP address of the EC2 server? No, right? Previously, the website was serving by one server, so I can use the IP address. But now there are two servers. I can't use the IP of a single server, right? So I don't want my users are sending the request to the IP of a EC2 server directly. Rather, let me go and deploy a load balancer here in my AWS cloud. Then whichever the servers that are configured as a identical manner which will be serving the same website, to eliminate the single point of failure, those servers I am keeping in a target group. You see here, these two servers I am putting into a target group in the sense the group of EC2 servers which are configured to serve you the same application. Okay, you keep them into a target group, and in this case, let's say this particular target group of servers are configured to serve you a shopper.com application. That means the first EC2 server, the second EC2 server, both are installed and configured a Apache HTTP web server to give you the shopper.com website only. There will be no difference, guys. Whether you access the website from first server or from the second server, you will get the same website. That's how we need to configure these two servers as identical. Whenever the client is requesting for the website, now rather the request is coming to the EC2 directly, like previously, the request will come to the load balancer. Now the load balancer will listen on port number 80 and port number 443. So far we know port number 80, right? Let me run the session with 80 only. I will talk about 443 definitely a bit later. Right, 443 is just for secure the website. Right, I kept you on mute. If any questions, put it in the chat window, guys. Well, whenever the client request is coming to the load balancer, the load balancer is actually forwarding that request to the target group. The client is sending the request to the load balancer port number 80. Now the load balancer is sending to a target group. Now the target group will be listening on port number same 80, and the target group is now responsible to send the traffic to any one of the EC2 server out of two available. Let's say your request will go to the first EC2 server, right? After some time, when the client is trying to access the website again the request will come to load balancer. Load balancer will give it to target group. The target group may give the request to second server. Again the third request is came, that will go to first server. Fourth request is came, go to second server. Fifth request, go to first server. Sixth request, go to second server. What does it mean, guys? Whenever the clients are accessing the website, the same website, right, the requests are actually equally balanced out of the number of servers that you have in your target group. It's a target group responsibility to route the traffic as a round robin fashion to ensure that all the EC2 instances are receiving the traffic equally, which is called as a load balancing technique. That means If there are 50 users are accessing my website, the 25 users request will come to one server, the another 25 will go to the second server. The request may come to any server. At the end of the day, the users are getting the same website, right? No difference. That's how you need to configure the both servers to be identical. We'll see how to do that. So the second advantage here is the load balancing, guys. That means rather putting the more load on the single server, we are distributing the load across multiple servers, so one server will not feel burden in serving the request for all the users. Are we good with this? Yes. Here the load balancer is responsible to route the traffic to the target group. Target group is responsible to route the traffic to both servers. It could be 2 or 3 or 4 or 10, guys. It's up to you. Got me? In my presentation, I'm maintaining 2, but it's up to you how many servers that you wanted to put in a target group, make it identical. It can be 10, 20, 30, right? The target group will just make sure that the traffic is equally distributed across all the servers. It's your responsibility to ensure that all the servers are configured in an identical manner. If those are not identical, one user will get a different website, the other user will get a different website, right? That should not be. So it's our responsibility to ensure that all the servers in the target group are configured in a identical manner, so that the request may come to any server, the user should get the same website. They should not feel any difference. Now, let's say I wanted to serve a one more website. So far I talked about www.edshopper.com website, right? If that website is executed, the request is came to my target group and all good. But what is the case? I wanted to run a one more business. Let's say www.edueki.com website. What to do now, guys? So I can configure in such a way that, right, I can take another set of 2 servers. These 2 servers can be configured to run a edueki.com related website application. These 2 can be put into a different target group. Following me, right? So in this case, the target group 1 has 2 servers. These 2 servers are configured as identical to serve a same website. The website is edueki.com. The second target group, which is configured with the 2 servers, these 2 are actually configured as identical to serve a website called edshopper.com. I have 2 websites that I'm serving here. One website from one target group, another website from another target group. I have total 4 servers. Here, the edueki.com request also can go to the same load balancer. This time, the load balancer can understand that, hey, the request is came from for which website. That it can analyze, guys. The type of the load balancer that I'm referencing here is the application load balancer. That means the application load balancer can aware of the incoming request website URL. The application load balancer can understand the incoming request URL, can understand and can route the traffic accordingly. That means if the end user is trying for edshopper.com, the request should go to the target group number 2. If the client is looking for edueki.com website, then the request should go to a target group number 1. That's where the edueki.com website is actually configured. That means if you have multiple websites, yes, it is possible to have one single application load balancer. having multiple target groups. Each target group is configured for one website, and you define a application load balancer rules saying that which website request should go to which target group. We can define a rules like that. Your application load balancer can follow the rules accordingly. It can serve the content to the corresponding target groups. Target group is just a logical entity that the AWS know how to manage or how to connect it, guys. Right? The end user cannot connect to the target group directly because target group is not something which will be accessible from the public internet, is not something which is listening on no HTTP from the end clients. That is just an internal AWS concept. We don't know how AWS will configure target groups and how they are managing behind the screen. We need to add a rule to the load balancer saying that, hey, when you get this request, you give to this target group. Whatever the rule that you give, it will just follow the rule and it will just forward the request to that target group. You just follow your rules. And you know, right, which target group is configured which website. You know that because you went and installed the web server software on the EC2 servers, you copied the code. So definitely you know which EC2 servers are configured with which website. So accordingly, you need to define your rules in a load balancer level. It will just follow your rules and just route the traffic. Target group is the logical grouping of your EC2 instances which are configured for the similar website for high availability, right? Within the target group, all the servers, whatever you are trying to keep, should have the same website configured. So that if one server is down, there is a one more server available which will be serving the same website. Whenever you have multiple EC2 instances are configured in the target group, configured with the identical website configuration to maintain the high availability, it's a target group responsibility to perform the health checks of your EC2 instances to know which EC2 server is healthy, which is unhealthy, so that whenever the target group received the request from the load balancer, the target group can verify, hey, out of two servers, which is healthy. If one server is unhealthy, the target group will ensure that the request is not going to that unhealthy server. The request will always go to the healthy server only. If both servers are healthy, it will follow the round robin fashion. If one is unhealthy, it always go to the healthy server only. What does it mean, guys? This is how we are eliminating the single point of failure. If one server is down for any reason, you don't need to do anything. It can understand that the server is down and it will stop sending the traffic to that server. It will send to any another healthy server only. That's how your end user will not feel any downtime. The website is continuously accessible, whatever is happening behind the screen. Why? We are configuring the load balancing and high availability concept by keeping multiple servers in my target groups. Are we good with this? Of course, we'll get into the implementation, but yeah, before that, we need this information, guys. When you are adding rules in your application load balancer saying that, hey, Based on the incoming URL, you decide the request should go to which target group. The rules can be added in multiple ways, guys. Even I can do the rules like this. I'm still doing something. This is just a theoretical concepts. Let it be. Right? You see now. Let's say the end user is accessing the website called edwiki.com/tutorials, or the end user is accessing the website called edwiki.com/assignments. Both are same website, guys. Correct? I'm changing the scenario now. The end client is accessing the same website or not in this case? The website is same, but if you see the slash, but they are using the different features probably, right? So one is a tutorial feature in the same website, the other one is the assessment feature in the same website, right? I can configure like this. One target group is installed and configured with the tutorial feature. Another target group can be installed and configured with the assignment feature possible. That means in this case, if you closely observe, right, both target groups are working for the same website, but one target group is providing the tutorial related features. The another target group is providing you the assessment related features, guys. Correct? For tutorial related features, I'm maintaining the high availability by keeping 2 servers in my target group. For assessment related feature, I'm maintaining 2 servers as a high availability in a different target group. Now I can tell to my load balancer that, hey, if you see the request is coming for /tutorial, you send it to the target group, whichever is giving the tutorial. If the request is coming from assessments, you see and forward it to the target group, whichever is providing the assessment feature. You got me what I'm trying to? That's how you can configure a n number of or different ways of rules in a target group. Sorry, in a load balancer, guys. Yes, as I see in a chart window, right? If you are using the youtube.com as an example, right? Yes, behind the screen, the YouTube guys are using the load balancer and the target groups and the servers behind the screen, right? So like in YouTube, you may be having multiple different features, right? Maybe a playlist, videos, maybe YouTube Studio, something. So each profile or each feature, you consider that there is a different target group. That's how they have maintained, and the load balancer know based on the feature that you are accessing from the youtube.com, it will be routing the traffic to the corresponding target group, which can serve the content for you. Now, let me make it more complicated. Whenever you are creating more than one servers to give you the high availability of that particular feature in a target group, try to ensure the servers are equally distributed across multiple availability zones. That means if you are creating the both servers in a 1A availability zone, as an example, if you create both servers in same zone, what is the case if the zone gets failed, guys? Got me? Zone is a physical data center, right, that the AWS is maintaining. Let's say you are creating the both servers in the same availability zone, 1A only. If 1A zone is failed, both servers are failed, correct? If both EC2 servers are down, your entire target group is down, your entire feature is down, your users not able to access that feature. So whenever you are trying to make a high available application, right, you make more than one EC2 server, good, and ensure that your servers are distributed it into multiple zones. One server you keep it in 1A zone, another server you keep it in 1B zone. Whatever I'm discussing, everything is happening within the single VPC only. Nothing is across VPC, guys. Everything is within the VPC only. Okay, but it can have 1A zone and 1B zone. That way, if 1A zone is failed for any reason, the corresponding server is failed, no problem. I have 1B zone corresponding server, your website is continue to be running. That's how we are addressing the zone level of failures as well here. Being said that, how do you decide, guys, your server should come up in 1A zone or 1B zone? Where do you decide first of all? Selecting the zone in which zone the server should come up is related to the subnet selection, correct? When you are selecting the subnet will decide your server to be get deployed it into which zone, because the zones are actually associated with the subnets if you look into the concepts. Being said that, always it's a best practice to keep one server in one subnet, the another server in another subnet. Just best practice. So one server will be get deployed into one private subnet mapped to 1A zone. Another EC2 server will be get deployed it into another private subnet mapped to a 1B zone. That means what? You need to have two private subnets, guys, so that you can have two servers deployed it into two different subnets into two different zones. It's a best practice. Now, correct now? All of your EC2 servers will be get deployed it into the private subnets, correct? Because my server should be secured, should not be accessible from public internet directly. Yes. But what about your load balancer, guys? Load balancer should be get deployed it into the public subnet, right? That is where your load balancer will be accessible from the public internet. Agree with me? If you look into this architecture, the end user is directly sending the traffic to the load balancer. That means your load balancer should be able to or should able to reach by the public people, right? That means your load balancer should be get deployed it into the internet connectivity. That means your load balancer should be get deployed into the public subnet. Then only your load balancer can have access to the public route table, can use the public route entry, can use the default route entry to the internet gateway. Correct? The load balancer, especially the application load balancer that I'm discussing here, is responsible to listen on port number 80 and port number 443 from your HTTP request and route the traffic to the backend. Your load balancer will not listen on any other port number. The application load balancer is designed specially for the HTTP related traffic only. It listens on 80 and 443 only, guys. It won't work on any other port number. Being said that, your application load balancer will not act as a NAT. NAT has its own purpose. Application load balancer has its own purpose. A question for you at this time. I'm creating a I'm creating a application load balancer in a public subnet, right? What is it mean by the public subnet, guys? The subnet also associated with any one of the zone, right? Correct? When you are creating a public subnet, the subnet is actually associated with any zone, right? Maybe a 1-year zone as an example. The question that I have here is, if for any reason the 1-year zone is failed completely, do I have a downtime at this time? Let's say the 1-year zone is completely gone. Somehow the data center is corrupted. Of course, you are maintaining 1-year zone and 1B zone for your private subnets, and you have both servers up and running. But if you look into your load balancer, guys, if you deploy your load balancer into one public subnet of one zone, if that zone is not working, your load balancer is gone. If your load balancer is not working, do you think your end client can reach the server? Not really. Hence the reason AWS will suggest you, hey, don't deploy your load balancer into one subnet. Rather, you always prefer to have your load balancer deployed it into at least two subnets of two different zones. That's the best practice. That's the mandatory to have. If you want to create an application load balancer in a public subnet, you have to use at least two public subnets of two different zones only, so that AWS will ensure the high availability. For any reason 1-year zone is down, you will not feel any downtime because you already said that it has to be available in 1B zone as well, so it will be still working for you. Now for you, it is a single load balancer, but in the backend, right, there will be two load balancers, guys. For you, it is a single load balancer. You create one load balancer and do everything. But from the AWS perspective, they will ensure that there will be one load balancer created in 1-year zone, one load balancer created in 1B zone. They do maintain a high availability in, right, with respect to the load balancer, and they know what to do in the behind the screen. You don't need to worry any of this. You just tell that, hey, I need a load balancer in 1A and 1B zone. For you, it is a single load balancer, but in the backend, they know what to do if a zone gets failure. A question for you at this time. Can a subnet is associated with multiple zones? Can a single subnet associated with multiple zones? Can a single subnet associated with multiple zones? Always no. Always no. A subnet cannot have multiple zones associated, right? How come a subnet can have multiple zones? Got me? One subnet can have only one zone. So when you deploy the server on the subnet, it will just deploy into the zone, correct? Now the question for you. Can a zone contains multiple subnets? A single zone can contain multiple subnets? Obviously, yes. So a 1-year zone can have any number of subnets that you want to. A zone can have multiple subnets, but a subnet cannot have multiple zones. Hope you agree with my statement. A zone can have multiple subnets, but a subnet cannot have multiple zones. Enough with the theoretical, right? We'll get into the practical now. Forget about anything that I have discussed so far, guys. What is that I need? Simply, I have my web server deployed in the private server. I wanted to access this website from the internet browser. For that, I need a load balancer. Simply put, I explained whole the concept in to deeper and deeper, but out of the game, I just need to deploy a load balancer to access my website, which is in the web server, correct? And probably to maintain the high availability, I need a two servers in the two subnets in the two different zones. That's the overall expectation, right? So what I do is to make this highly available, right? I will go to the VPC one more time because as of now, I have one public subnet and one private subnet. To make it more highly available, even from the zone failures, I should have at least two subnets in the two zones, right? Hence the reason, let me go ahead and create a one more subnet and one more public subnet and one more private subnet. So as of now, the private subnet that is currently created is in the 1A zone. So I'll create a one more private subnet in the 1B zone. This is the private subnet 02. Already I have a private subnet in 1A, right? Now I'll do it in 1B. 192.168.3.0/24. Done. Now, as of now, the public subnet is in 1B. Let me create a one more public subnet in 1A. I'm just trying to ensure it is using both zones. This is a public subnet 02. 192.168.4.0/24. When you created a subnet, you should ensure that these subnets are using your route table. I'll go to the private route table, to the subnet association, edit subnet association. Now I will select my another private subnet as well. You see, these two private subnets are using the private route table. These two private subnets are in 1A and 1B zones respectively. Now I'll go to the public route table, subnet association, edit, and I'll tell that, hey, the second public subnet also should use the public route table. Are we good with this, guys? I just have prepared two public subnets, two private subnets in 1A and 1B zones. Currently, I have a private server here, right, which is already installed and configured as a web server, correct? This private server is deployed where you see it is currently in 1A zone. What I do now, I will create a one more EC2 server, right, in 1B zone. Are we good with this? Right? Because currently my private server, my web server is in 1A, right? Now I'll create one more server in 1B so that if zone failure, still my website should run. That's the reason. Launch instances. I'm just creating a one more web server. Just go with the AMI instance type, key pair, networking settings. Use it in the same VPC. You see here, I will just go with a private subnet with 1B availability zone. Okay. Now Let me choose the security group from the drop down. I'll just give the IAM role just for best practice. Just come down and launch a server. I have total 2 EC2 instances configured as a web server. Of course, I need to do the configuration now. This is my second private server. Take the IP. Now let me log into this server as well. I will configure this server as a web server, guys. So I will exit from this first 1A zone private server. Now I will log in to my second private server. I'm just logging in from based-in server. Okay, so I just logged into my second private server. Yum install HTTPD. This is already attached to the private route table, having the entry to route the traffic to the NAT gateway. It should be able to download the packages from the public internet space. Of course, it's hard to follow my sentences. Yeah, that give the clarity, guys. Systemctl start HTTPD. vi, let's say var www html index.html. This is my website. It's your responsibility to ensure that the both servers are configured with the web server with the same code. It's up to your responsibility. Okay, as of now I'm doing manually, but we'll make it more betterment later. What is done so far? I created 2 EC2 instances, both are configured as a web server. Now the time for you to create a target group, then load balancer. Just 2 steps. In the EC2, in the left side navigation, if you do little scroll down under the load balancing section, you can see a target group tab. Just go there. Just click on create a target group. It's asking that, hey, you want to create a target group by keeping what in your target group. What is that I wanted to be in my target group, guys? Here, what is in my target group? EC2 instances, right? So select instances here. AWS is making more complicated by adding all these different options. Don't worry about all of these, guys. As of now, my requirement is I wanted to keep instances in my target group. Select that option. Which port that your target group is trying to listen on? This is my web server target group. As of now, it is 80, right? By default. So let it be 80 port number. So HTTP protocol, port number 80, it has to listen on. IPv4. My target group, I wanted to deploy in the web VPC 01. Let it be default protocol version, all these things, doesn't matter. Now come to here, health checks. Come back to this one more time, guys. Maybe a question for you. How do you ensure that your server is healthy? Let's say here I have one EC2 server, right? How do you ensure that the server is healthy? Any clue? On what basis you will tell that the server is healthy? Whenever I say a server is healthy or not, I always look from the business perspective. That means if I send a HTTP request on port number 80, if I am getting the response then I will consider that my server is healthy. Are we good with this statement? That is what I needed. I really don't care about any other things, right? If your server is giving the response on port number 80, then your website is working. If your website is working, your server is healthy. That's it. So I need to look at whether your server is reachable on port number 80 or not, whether it is giving the response or not on the port number 80. That is the only best way to check the server health status. So here your target group is checking the health status of each server, right? Because if at all the server is not healthy, the traffic will not come to the server. Always it will go to the healthy server. How it know that the server is healthy or not? I need to tell to a target group that, hey, you please check if the port number 80 is working or not. If it is working, server is healthy. If it is not working, the server is not healthy. Don't give the traffic. That is where we need to tell the health check settings here. I'm telling that, hey, use the HTTP protocol, right? Use the HTTP protocol and use the traffic port in the sense 80. If you want to mention, you can mention here, hey, use the 80 port number. Or if you say traffic port, it automatically understands that port number 80, right? Use the HTTP protocol and send the traffic to the traffic port, right? Traffic in the sense the heartbeat packets, right? Whenever you get a response, you understand that the server is healthy. If you don't get a response for any reason, consider that the server is unhealthy. Now you have more options, guys. Healthy threshold, unhealthy threshold, lot of other things. Very important thing is interval. Definitely it has to verify the server is healthy or not very frequently, right? If the interval is 30 seconds, it is keep checking whether your server is healthy or not for every 30 seconds once. Every 30 seconds it will go and check whether the port number 80 is reachable or not. If it is, server is good. If not, no, don't send this traffic to the server. That's how you need to configure the interval, how frequently it has to check for the server status. If at all response on this port number is, if the HTTP response code is 200, then you consider that the server is healthy. If not, don't consider that the server is healthy. That's how we can even tell the HTTP response code here. We already don't know this, right? HTTP response code 200. 200 means successful. Don't worry about the other options, guys, for now. That makes more theoretical. We'll talk about that later. For now, I'm just configuring the health checks. Go next. Now it is telling, hey, tell me which server you wanted to keep in the group. I want to keep my both web servers, right? So include, I just added my both servers, create a target group. I'm done. Now you see here, I have created a target group. This target group has two servers, and you can see here, it has two servers. Currently you see that the two servers are unused status. Why it is showing unused? As of now, I only created a target group, right? But this target group is not attached with a load balancer. So when you created a target group, it is showing it as a unused. The moment when you attach this to the load balancer, then it will start using and it will start performing the action. I think in next 5 minutes we can complete the setup. We already done, right? Almost. The target group is ready. The only thing is just go to the load balancer tab here, right? And just click on create a load balancer. Interesting. There are different type of load balancers that you can create in the AWS application, network, gateway. Don't worry about all of these for now. We talked about application load balancer. Let me go and create a application load balancer for now. We'll see the difference later. Now the load balancer name, this is my web server load balancer. Tell me guys, your load balancer to be a internet facing? Yes, right? My load balancer should be accessible to the internet. So select internet facing for now. Don't go with internal. Internal is like again within the VPC, which I don't want. Always IPv4. Select the VPC, in which VPC you need a load balancer. Select the subnet, in which subnet you wanted to have your load balancer. In 1A zone, right, I select the corresponding public subnet. In 1B zone, I will select the corresponding public subnet. You see here, I'm actually selecting the two subnets of two different zones for my load balancer as well. That's how you will be maintaining the high availability, and that is a mandatory, guys. Whatever I discussed theoretically, I'm just doing the implementation here, right? Just a security group selection. Hey, load balancer, you need to listen on port number 80. Whatever the request that you get it on port number 80, that request you need to forward to the target group, right? You select the target group from the list here. That's it. Now, whichever the request that comes to port number 80, it will send to this web server target group. This target group is already having the two instances as a target, right? That will get the request. Just come down and create a load balancer. Done. We are already done. We are done with the complete setup, guys. Now it is actually provisioning the load balancer, and now let me go back to my target group and let me see the status here. This is my target group, and look at the targets here. Let me refresh once. Now the targets are showing initial, in the sense the target group is performing the health checks on these two EC2 servers. If the health checks are passing, then your targets will come to a healthy status. If the health checks are failing for any reason, your targets will be marked as a unhealthy and will not receive the traffic. It takes some time to understand that your server is healthy. Once the server is healthy, then only the servers will receive the traffic, or else no. While it is doing right, if I come back to my load balancer here, this is my load balancer, right? Whenever you deploy the load balancer, the load balancer will be created with a DNS name. Whatever the DNS name that you get from the AWS, that is the DNS name that you need to use to access your website, guys. Take that DNS name, go to the browser and use that DNS name to access the website. Right? So you need to take this DNS name and send the HTTP request from your browser to that DNS name. This is the load balancer DNS name. That way the client is sending to load balancer. The load balancer give it to target group. The target group will give to one of the target, that is your EC2 server, and that will give the response back. You see now, my target is unhealthy. That is the reason my website is not working here. Right? So your target should turn into healthy status, then only the response will come and your website will also run. If you don't want, you need to access the website using this lengthy name. This is not the way to access the website, right? But your load balancer has got this name. All what you can do, right? Go to your Route 53. Right? In the Route 53, you need to create a record. Let me remove the existing ones. Right? Create a record saying that www.edshopper.com should be resoluted to your load balancer DNS name. Whenever a name is resoluting it into one more name, then your record type should be CNAME. Previously it was a record, right? When the value was IP address. When the value is also a name, one name is converting into another name, then it is a CNAME. Just create a record. Now you should be able to access your website as www.edshopper.com. So this will convert to DNS of your load balancer. The DNS of your load balancer will be converted into IP automatically by the AWS. Then it will go to your load balancer. Finally, the things will be working out. That's okay. Here my website is not working because it is unhealthy status. Will make it into healthy and will continue the remaining question marks that we have on this setup in tomorrow again. I'm just checking the security group, guys. You see that in the security group, the port number 80 is not there. How come it will be accessible, correct? So let me allow the port number 80. Now come back to target groups one more time. Let me refresh. We'll wait for some time, okay? So I updated the security group, right? So now it should be accessible. Yes, it will be a little confusing, but yeah, we can go through the session one more time and I'll be doing little more discussion on the same topic tomorrow as well to make it more clear, guys. But yeah, maybe I'm going in deeper to make it every concept clear. That's where you may be seeing some, right? But if I go ahead high level and just quickly configure, that will be a like by-hatted way, which doesn't help for you much, okay? Let me check the security group one more time. If any questions, do let me know, guys, or else we are good for today. I'll check this. HTTP is allowed from anywhere. This is good. So I just need to wait for some time probably. Interesting. The website is working. Why it is showing not healthy? Something wrong in my AWS? Yeah, I think I have to refresh from browser phase. Okay, you see that? I have to refresh from browser. You see here like the both servers are showing healthy now after enabling the security group. Now you see www.edshopper.com is working. When you refresh this response, right, may coming from first server, may coming from second server. Either the case your website is same because you kept the code in both servers same way, identical way. So if any server is down, let's say I'll bring down the server, and this is one server. If one server is down, your website will not go down, guys. So I actually stopped one of the server. You see the server is stopped. Sorry. If one server is stopped, that server will show it as a out of service here. It takes some time, right? That will show it as a out of service, like unhealthy, but still your website should work. That's what it is called as a high availability. You see that the server is not showing here. Only one server is working, but your website should continue to be working here. Well, team, so I think that's the whole concept, and good thing is it is completely working at this time. Yes, as I see in a chart window, for a second, it may show you 502 bad gateway for a second, but it should back to working immediately. Okay. We can do a lot of other improvements to ensure that everything is working as expected without having that second duration also. But yeah, for now, it's a good observation. Maybe that particular second, the request is trying to go to the unused server or unhealthy server, maybe the reason. But yeah, but you see that the website is working fine. Well, team, so if any questions, do let me know, or else we are good for today. We'll talk about the listener rules tomorrow, like how do you configure the rules in your load balancer to give to multiple target groups. As of now, I configured only one target group, right? If you have one more target group, how to make the rules, we'll talk about that, and we'll continue the session to make it more enhanced. Okay. So that's the story for today. I hope you like the today's session. It has included a lot of concepts, right? And if any questions, do let me know. And regarding the NAT gateway, right? The NAT gateway is billable on hourly basis, and I think it's like pro rata basis, right? Even if you run the NAT gateway for 15 minutes, I believe at least there will be 5 cents, 5 cents of billing will be generated. I believe it will be there's something will be generated, guys, right? So don't worry, but just do little practice there and terminate a NAT gateway once done. Thank you, team. It's a nice
Uh,
informative session. Go ahead, please.
Regarding like accessing the private server from the public server, like at the beginning we have given the password and then we have gone into the private server. There, the key will be stored in /etc. That is fine, but it is based on the file we attach when we are logging into Putty. What if we have the other key pair attached for one server and another for the like one for public and another for private? Here we are using DPT11 for both the servers.
So it doesn't matter about from which server you are logging in. The concept says that to which server you are trying to log in, right? You need to use the corresponding matching public and private key combination. Let's say, forget about this Bastion host. I don't care about which key is being used for my Bastion host. If I'm logging into the web server, for my web server, what is the key pair attached? Now take the private key of this key and use it for login. That's it. I'm not worrying about this.
Okay.
What the concept says, whenever you are logging into the server,
Mm-hmm.
concept says This is my server and this is my client. Forget about two EC2 servers or party to EC2 server, whatever it is, right?
Yes.
From
Yes.
which machine you are initiating the connection, that is the client, and
Yes.
to which server you are trying to connect, that is the server.
Mm.
The concept says that the client side you need a private key. The server side you need a public key. Then you log in from client to the server. That's the concept.
So here the
Whenever
client putty and the private key is the file we are attaching in putty while logging in.
here the client can be a putty, or the client can be a bastion host, or the client can be any other server, any other machine. I don't care, right? Whenever you have created this EC2, this is EC2, right?
Hmm.
Whenever you created this EC2, you have attached a key pair for this EC2 server. In my case, the DPT11 is the key pair that is attached to the server. Whenever you have attached this DPT11 key to the EC2 server, AWS will ensure that this, whenever you say DPT11 key, right, this is having public and private key, correct?
Yes.
This is having public and private key, right? So usually when you create a key pair, the private key is downloaded to your local machine. The public key will be get copied it into the EC2 server by the AWS automatically into a authorized underscore keys file, correct?
Yes. Yes. I got it now. Like I thought the file we are attaching is downloaded into authorized thing. Now I get it.
Right? So this private key is downloaded to your machine. So this is the key that you need. You log in from Putty, you log in from Bastion, you log in from anywhere, I don't care. From which machine you are trying to log into this server, in that machine you need this private key, right? If it is Putty, I'm able to attach directly. If it is Bastion host, what I did, I converted my key into a different format because that should be in a PEM format. Then I copied the key to the Bastion host. From there, I used the command, I attached the key and logged in. Same concept, right?
Yes. Like in previous concepts, we have copied the public key in that server.
In that is a different case. There, what I shown you, right? Let's say I don't want to use this key for login.
Oh, we have generated our own keys and then we
Yes.
copied the public key. Yeah, yeah. Okay.
Yes. If I don't want to use this AWS provided key combination, then you generate your own public and private key. Then you copy yourself the public key here. You copy the private key to your client side and you log in. That's
Yeah,
your own set of keys combination.
yeah, yeah. Thank you so much. Yeah, it's very clear now.
Thank you.
Is target group VPC level?
Sorry.
The target group, we said that you can have like
Not really. Always remember yeah. When you're talking about the scoping, right? The scoping will happen only at a service level, not a resource level. Okay. We will not talk about resource level scoping, right? That means VPC is the region level resource, EC2 is the region level resource. That's the concept. Target group is the VPC scope. I think that doesn't make more meaningful because within the EC2 service, all these resources will belonging into the EC2 only. And within the VPC, right, all the resources will belonging into the VPC only. You got me?
yeah. Then you said within the target group you had servers from different zones, right? Like in the image. So
It can
how would
be.
you be able to reconcile
That's the
this?
reason. That's where like the target group is scoped into the VPC. That terminology itself will not make more meaning. That's what I'm trying to. We'll never use the term here. The target group is just a grouping of the server, nothing much. Just a logical group. It never exists. It's just a logical group. Why it is a logical group? Whichever the servers are identical to give you the high availability, I just need to make it into one single group and tell to my load balancer, hey load balancer, you please send this to this target group. Just for that particular purpose, I'm making the servers into a group concept. That's it. You got me?
So,
If you don't have this grouping concept, right, how do I tell to my load balancer that the request should go to where? Right? So the AWS made a grouping concept so that it's very clear for me that this particular group is serving one website, the another group is serving another website. So it's very easy for me to configure the things like the request should go to which group. Got me?
yeah. So the distribution of work is done by target group. But what about in case of load balancer? You said like we can have multiple load balancer in case of one fails. So who manages those load balancers, rerouting and everything? So is there any tool that's behind it, or?
You can have only one load balancer from your perspective. AWS will actually use multiple load balancers behind the screen, which is fully transparent, which is not visible from your side. You will never know that there are multiple load balancers. But strictly speaking, it will be like this. Let me redraw the diagram again. Strictly speaking, the concept will be like this. This is how it works. Your request will go to one load balancer that actually routed to different load balancers behind the screen for high availability purpose, like this. The request may go to 1A load balancer or 1B load balancer that again take care of routing the traffic to backend target groups. This is how AWS will maintain multiple load balancers spreaded across multiple zones for high availability. If one zone is failed, no problem, because I have another load balancer in another zone that take care of. This is the actual concept behind the screen, guys. But for you, you don't need to worry about these load balancers. For you, it is a single load balancer. You work as like you have only one load balancer. How it is working behind the screen with multiple load balancers to make you high available load balancer, it's up to the AWS, which is fully transparent for us.
Thank you.
Thank you. And as I said, all right, answering to the question in the chat window, how we can give multiple target groups to the single load balancer, that is what we are going to discuss tomorrow. Thank you.